Concrete encased electrodes, or CEEs, should only be spliced using non-reversible methods. These methods include CAD welding, approved crimps, and irreversible split bolts. Irreversible split bolts specifically designed for concrete encased electrodes are available. They typically have a deformation or locking mechanism that prevents them from being removed once installed. The use of crimp sleeves on concrete encased electrodes is not recommended. In a situation where concrete encased electrode wires have been cut, the use of a crimp sleeve is not an approved method for splicing concrete encased electrodes and does not meet code requirements. Acorn connectors are also not irreversible unless modified. Using them in this manner would not meet code requirements either. To ensure compliance with code and maintain the integrity of the grounding system, you should use the following recommended solution. Firstly, remove the existing concrete encased electrode wires that were cut off. Secondly, extend the concrete encased electrode wires using a new section of concrete encased electrode spliced with an irreversible method such as CAD welding. Thirdly, ensure the new splice is properly protected and sealed to prevent corrosion. It is important to have a constructive discussion with the authority having jurisdiction regarding the limitations of concrete encased electrode splicing. Explain the code requirements for irreversible splices and the risks associated with using non-approved methods. Emphasize the importance of maintaining the integrity of the grounding system for safety reasons. Grounding and bonding are critical aspects of electrical safety, designed to minimize the risk of electric shock and ensure the proper operation of overcurrent protection devices. A concrete encased electrode, often referred to as a CE or U for ground, is a type of grounding electrode that is encased in concrete. It is typically used in new construction, where it is embedded within the concrete foundation or footing of a building. The National Electrical Code, or NEC, outlines specific requirements for grounding and bonding to ensure electrical safety. Article 250 of the NEC covers the general requirements for grounding and bonding, while specific sections address the installation and use of concrete encased electrodes. According to the NEC, a concrete encased electrode must be at least 20 feet long and consist of either a number 4 or larger bare copper conductor or a half-inch or larger steel reinforcing bar or rod. The electrode must be encased in at least 2 inches of concrete and located within the bottom of a concrete foundation or footing that is in direct contact with the earth. The primary purpose of a concrete encased electrode is to provide a low impedance path to ground, allowing fault current to flow back to the source and trip the overcurrent protection device, such as a circuit breaker or fuse. This helps to prevent electrical shock hazards and minimize the risk of fire. When installing a concrete encased electrode, it is essential to follow the NEC guidelines and ensure that the electrode is properly connected to the building's grounding system. This typically involves connecting the electrode to the main grounding busbar or grounding electrode conductor using approved methods such as exothermic welding or listed connectors. Proper splicing of concrete encased electrodes is crucial to maintain the integrity of the grounding system and ensure its effectiveness. According to the NEC, splices and grounding electrode conductors must be made using irreversible methods such as exothermic welding or listed compression connectors. These methods provide a permanent and reliable connection that is resistant to corrosion and mechanical stress. Irreversible connections are essential for concrete encased electrodes because they are buried in concrete and are difficult to access for inspection or maintenance. A failure in the splice could compromise the effectiveness of the grounding system and create a safety hazard. Exothermic welding, also known as CAD welding, is a process that uses a chemical reaction to create a permanent metallurgical bond between the grounding electrode conductors. This method is commonly used for splicing concrete encased electrodes because it provides a strong, corrosion-resistant connection that meets the NEC requirements for reversible splices. Listed compression connectors are another approved method for splicing concrete encased electrodes. These connectors are designed to be mechanically crimped onto the grounding electrode conductors, creating a secure and reliable connection. The connectors must be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL, and must be suitable for direct burial in concrete. The NEC prohibits the use of mechanical connectors, such as split bolt connectors or set screw connectors, for splicing grounding electrode conductors in concrete encased electrodes. These types of connectors are not considered irreversible and may loosen or corrode over time, compromising the integrity of the grounding system. When splicing a concrete encased electrode, it is essential to ensure that the splice is properly protected from corrosion. This can be achieved by applying a corrosion-inhibiting compound to the splice and wrapping it with a waterproof tape or sealant. The splice should also be located in an area where it is protected from mechanical damage, such as within the concrete foundation or footing. In situations where the concrete encased electrode is damaged or needs to be extended, it is important to follow the NEC guidelines for splicing grounding electrode conductors. The damaged section of the electrode should be removed, and a new section of electrode should be spliced in using an approved irreversible method, such as exothermic welding or a listed compression connector. The splice should be properly protected from corrosion and located in a protected area. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and ensuring that electrical installations comply with the code requirements. The AHJ may have additional requirements or interpretations regarding the splicing of concrete encased electrodes, so it is essential to consult with the AHJ before beginning any work. In summary, concrete encased electrodes are an important component of the building's grounding system and must be installed and spliced according to the NEC guidelines. Splicing grounding electrode conductors in concrete encased electrodes requires the use of irreversible methods such as exothermic welding or listed compression connectors. Mechanical connectors are not permitted, and all splices must be properly protected from corrosion. Consulting with the AHJ is essential to ensure compliance with local requirements and interpretations of the NEC. Proper grounding and bonding are critical for electrical safety, and following the NEC guidelines for concrete encased electrodes is essential to minimize the risk of electric shock and fire. In the context of electrical engineering and safety, the integrity of grounding systems is paramount. Grounding systems, including concrete encased electrodes, serve as a critical safety measure to protect individuals and equipment from electrical faults. When dealing with concrete encased electrodes, or CEEs, it is crucial to adhere to specific guidelines and regulations to ensure the effectiveness and longevity of the grounding system. One of the most important aspects of working with CEE is the method used for splicing or connecting the electrode. The National Electrical Code, or NEC, provides clear guidelines on acceptable methods for splicing grounding electrode conductors, particularly those used in CEE. According to the NEC, grounding electrode conductors must be spliced using irreversible methods. Irreversible methods are those that create a permanent, reliable connection that is not likely to loosen or corrode over time. These methods typically involve either exothermic welding, also known as CAD welding, or the use of listed compression connectors designed for grounding applications. Exothermic welding is a process that uses a chemical reaction to create a molten metal that fuses the conductors together. This method provides a robust, corrosion-resistant connection that is ideal for grounding applications, especially in harsh environment. Listed compression connectors, on the other hand, are mechanical connectors that are specifically designed and tested for use in grounding systems. These connectors are typically made of copper or aluminum and are installed using a specialized crimping tool. The tool applies high pressure to the connector, creating a secure, cast-tight connection that is resistant to corrosion and mechanical stress. The NEC explicitly prohibits the use of mechanical connectors, such as split bolt connectors or set screw connectors, for splicing grounding electrode conductors. These types of connectors are not considered irreversible and are prone to loosening or corroding over time, which can compromise the integrity of the grounding system. When splicing a CEE, it is essential to follow the manufacturer's instructions for the selected splicing method. This includes using the correct tools, preparing the conductors properly, and applying any necessary corrosion inhibitors or sealants. The splice should also be located in a protected area, such as within the concrete foundation or footing, to minimize the risk of mechanical damage or corrosion. In situations where the CEE is damaged or needs to be extended, it is important to remove the damaged section and splice in a new section using an approved reversible method. The splice should be made as close as possible to the original electrode to maintain the effectiveness of the grounding system. It is also important to ensure that the new section of electrode is of the same material and size as the original electrode to avoid creating a dissimilar metal connection that could lead to corrosion. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and ensuring that electrical installations comply with the code requirements. The AHJ may have additional requirements or interpretations regarding the splicing of CE, so it is essential to consult with the AHJ before beginning any work. In addition to the NEC requirements, there may be local codes or regulations that govern the installation and splicing of CE. It is important to be aware of these requirements and to comply with them to ensure the safety and integrity of the grounding system. Proper grounding and bonding are essential for electrical safety, and following the NEC guidelines for splicing CE is crucial to minimize the risk of electric shock and fire. By using approved irreversible methods and following the manufacturer's instructions, you can ensure that the grounding system is reliable and effective for the life of the building. The role of irreversible connections in grounding systems cannot be overstated. These connections, as the name suggests, are designed to be permanent and unyielding, ensuring a continuous and reliable path for fault currents to flow back to the source. In the context of concrete encased electrodes, the need for irreversible connections is even more critical due to the inherent challenges associated with accessing and maintaining these electrodes once they are embedded in concrete. There are several reasons why reversible connections are essential in grounding systems. Firstly, they provide a high level of reliability. Reversible connections are designed to withstand the test of time and environmental factors, such as moisture, corrosion, and mechanical stress. This ensures that the grounding system remains effective even under adverse conditions. Secondly, they minimize the risk of loose connections. Loose connections can create resistance in the grounding path, which can impede the flow of fault currents and increase the risk of electric shock or fire. Reversible connections, on the other hand, are designed to maintain a tight, secure bond between the conductors, preventing the development of loose connections. Thirdly, they simplify maintenance. Irreversible connections eliminate the need for periodic tightening or replacement of connectors, reducing the maintenance burden and the associated costs. Once an irreversible connection is made, it is designed to last for the life of the grounding system. Fourthly, they enhance safety. By providing a reliable and continuous grounding path, irreversible connections help to protect individuals and equipment from electrical faults. This is especially important in applications where safety is paramount, such as hospitals, schools, and industrial facilities. There are several methods available for making irreversible connections in grounding systems. The most common methods include exothermic welding, also known as CAD welding, and the use of listed compression connectors. Exothermic welding is a process that uses a chemical reaction to create a molten metal that fuses the conductors together. This method provides a robust, corrosion-resistant connection that is ideal for grounding applications, especially in harsh environments. The process involves placing the conductors in a mold and then igniting a mixture of copper oxide and aluminum. The resulting chemical reaction produces molten copper, which flows into the mold and fuses the conductors together. The mold is then removed, leaving behind a permanent, metallurgical bond between the conductors. Listed compression connectors, on the other hand, are mechanical connectors that are specifically designed and tested for use in grounding systems. These connectors are typically made of copper or aluminum and are installed using a specialized crimping tool. The tool applies high pressure to the connector, creating a secure, gas-tight connection that is resistant to corrosion and mechanical stress. NEC requires that compression connectors used for grounding applications be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. This listing ensures that the connectors have been tested and found to meet the applicable safety standards. When selecting a method for making irreversible connections in a grounding system, it is important to consider the specific application and the environmental conditions. Exothermic welding is generally preferred for applications where corrosion resistance is a major concern, such as in direct burial applications or in environments with high levels of moisture or chemicals. Compression connectors are a good choice for applications where ease of installation is a priority or where exothermic welding is not practical. Regardless of the method chosen, it is essential to follow the manufacturer's instructions carefully to ensure that the connection is made properly and that it meets the applicable code requirements. In addition to the NEC requirements, there may be local codes or regulations that govern the installation and splicing of grounding electrodes. It is important to be aware of these requirements and to comply with them to ensure the safety and integrity of the grounding system. Proper grounding and bonding are essential for electrical safety, and the use of irreversible connections is a critical component of a reliable and effective grounding system. By understanding the importance of irreversible connections and by following the applicable codes and standards, you can help to protect individuals and equipment from the hazards of electrical faults.